Number three on 2014 is a two-dimensional array, so a matrix, which we won't technically have a matrix, but we could have a question just like this in our test with a one-dimensional array. So it's still really good practice, just changes a little bit how we write the loops is all. And this is just another example of a user-defined class. So we've seen a lot of these if you've been trying all the free response questions together. So this one's called a student. That's just something they made up for this test question. We don't really know what this class looks like. They don't show us any instance fields or constructors. They just share with us two methods. So there's a string method, which gets the name of the student, turns it as a string, and then there's a get absence count, which tells us as an int how many absences they have. Neither of these methods require anything from us. They're both parameterless. This is a great example. If you remember some of the problems earlier, they had interfaces, and I mentioned how even though we're not testing interfaces this year, that those questions were still really applicable to us. They could have easily said here public interface student, and it wouldn't really change any code that we write for this question. Like, we'd still just have to understand that there's two things that you can do to a student. You can get their name and you can get their absence count. So the fact that they made this as a class as opposed to an interface really doesn't impact the problem at all on our end. So these, well, I mean, I guess you can make a matrix, or it doesn't matter. You could. This is fine. So we have a student matrix here called seats. Now this is a two-dimensional storage system, which we won't see on our exam, but that's not a big deal. Like I said, we'll just have to write one extra loop. So you should still be able to practice this problem. And it's really important to note that this is holding student references. We don't really know what a student is. Like, if you think of like a student in PowerSchool, there's probably like 200 data fields associated with every student. But we just know that they have names and absence counts somewhere in there and that we can get them. So if you give me a student, I can ask for its name or for its absence count as a string or as an int. So in part A, we're writing the constructor. Okay, how do I know it's a constructor? Well, it's got the same name as the class seating chart, and there's no return type. Okay, as soon as I see that, I start thinking to myself, okay, if I'm writing code for a constructor, my first job is that I have to initialize all the instance fields that belong to this class. And I only have been made aware of one, it's that student matrix. This matrix has only been declared, it has not been initialized. So my first job will be to take seats and say seats equals new. What is it? It's a new student matrix. Okay, so seats equals new student. To make it a valid matrix, I'll have to give it two dimensions, a number of rows and a number of columns. They've handed me both of those as ints, rows, and cols. That will create the matrix. The matrix will be filled with null pointers at that time. I need to take the students from this list called student list then and put them into the matrix. And when I do that, I'm putting them in column major order. So that means that we're actually going to pick a column and we're going to put the students into that column going through all of its rows. So it's a pretty easy thing to do. It just means you write your column loop on the outside of the row loop, and then it handles that. They might not give me enough students. So they warned me that empty seats are going to be represented by null, and that rows times columns, that's how many seats there are, is guaranteed to be at least student list.size, but it might be greater. So we might not have enough students. We'll never have too many students, but we might have less than enough. And they go on to explain that a little bit more in part A, like they show you like some nulls. They show that column major order. So Karen, Liz, and Paul fill column 0 as opposed to filling row 1. Okay, so again, when we're writing a constructor, you have to remember to initialize any instance fields. Very likely that this is on your exam, and this would be like a point on the rubric. Okay, so we set this matrix up and we need to provide two dimensions. Okay, and that's why they handed us two ints named rows and cols. All right, so I still set this up as rows by columns, even though I'm going to fill it in column major order. I'm just going to write on the outside a column loop. Okay, and you could use either cows here or seats 0.length. Those would both be acceptable for your control. All right, and so there's my outside loop. My inside loop is going to look just like it, but it's going to walk across every row. So pick a column, visit all of its rows, and you'll be walking through the matrix in column major order. All right, what do we do when we get there? Well, the whole reason that we created that double subscript is so that we can access one of the seats, right? So give me seats at RC, and I need to hand it from the student list one of the students. Now it's an array list, so I have to use my get method. I need an index. I need a way to access the array list. You could do some tricky math with C and R if you want to try it, or normally what we've been doing is just when we have that third storage piece there is we just make our own index for it, and then we'll just advance it each time. So put a student in, get a student from the next position in the list. Now, if you did this, you'd still be kind of missing one point, maybe two, because I have sort of two issues here. One is eventually I might run out of students. So remember that they're not guaranteeing to give me enough. So I should only attempt this process if I am confident that I is less than student list dot size. Okay, I need to verify that first before I attempt to put somebody in to the matrix. Okay, so what do I do then if I'm not meeting this criteria? Well, if I'm not meeting this criteria, then seats RC by the directions is to be filled with null. Now, you don't actually have to do this. And the reason is this would default to null anyway. So at the moment that we create this matrix, everything in it is defaulted to null. So you could write that line of code. It wouldn't be wrong to, but it would also be correct to omit it. Because like I said, at the point of creation, it's already filled with null values. So you'll notice that even though I didn't specifically say to put null into those two seats, it did show up in my tester for part A, okay, because of how it was defaulted to those values anyway. All right, now in part B, we need to remove some kids from the matrix, but it's a little different than that remove method we wrote in number 1 from this test. That was an array list, so we had to actually use the remove method. An array list is dynamic in its size. It can change as you remove. We're not actually looking to change this matrix around. So we're not supposed to change the size or the seating structure or anything like that. We're actually just replacing with null. So to remove a kid here means really that you're going to replace them with null. So you need to take a student from the matrix, and then at that point, if you have a student, which anything that comes out of that matrix is a student, you can then get their absence count. If the absence count is too high, we replace them with a null. Now, there is another trick to this problem. You can't get the absence count of a reference that already is null. So for example, like if we were going across this seating chart and we came to the seat here that was labeled null and we asked for the absence count, you can't do that. You can't ask for the absence count of something that doesn't exist. You'd get a null pointer exception in your runtime. So we're going to have to avoid things like that. Why would we want to replace that student? There is no student there to begin with. So we're only going to look to replace objects in this matrix if there's actually a student there. And we would need to pick up on that. And, they did kind of draw our attention to it again. They wrote the word null right there in the directions. So, and then we're also actually keeping a running count for how many students get removed. Okay, so we're going to return the number of students removed. So this is on top of the replace remove. We also have a counter method showing up here as well. Now, I can't use my methods loops from part A. Okay, rows and cols, remember, they get destroyed as soon as this happens here. You could write a column major loop, okay, but you can't use those int rows and columns values. So whether you go row or column order here doesn't really matter, but we are going to have to rely on seats.length to get our row count, and we're going to have to rely on seats0 or seatsr.length to get our column count. All right, so here's my row column loop structure. And so now I'm ready to start walking through this array. But like I said, I got to be a little careful where I visit in this matrix, because if seats RC happens to be null, I can't ask for an absence count. So I really only want to look at seats that I have first verified are not null. Now, once I've verified that they're not null, then I can go ahead and get their absence count. Okay, and once I have their absence count, if it exceeds this argument right here, this parameter coming in, allowed absences, then I am to remove them. But remember, to remove here is a little bit different meaning than like we might see in an array list. We're not going to call it a remove method. We're looking to just replace. And this is not an array list. There's no set method now. So you can actually assign into an array. And so we'll assign in the value of null. And we need to also count that student. So better brace this since we have two pieces attached to it. And we'll bump up our counter, and then should come back. If you wanted to join these two ifs, you could with an and. Okay, that would employ the short circuit. Just make sure that your null check comes first in that line. And if you look here, see how there's like this 5 null values, right? There were 2, and now there's 5, so we counted 3. And this is correct. If you came back and compared to their example, those kids there, Henry, Fran, and Renee all got removed because they had too many absences, okay? So yeah, this looks good. Now, I mean, like I said, we won't have to write that interior loop to walk through a matrix on our exam, but otherwise, this is a great practice problem. I mean, we've got methods and control structures because there's a user-defined class called student, and we had to figure out on the spot what its methods were and what it could do. And we also have a data structure here where we have an array that we had to walk through. Okay, and so yeah, this is exactly like what we might see on our exam. It would just be in a one-dimensional array as opposed to a two-dimensional.